This video is the second one on naming of alkenes. In any case, I would suggest you stop at this point, read section 5.2a, short section on pages 187 to 188. As you read that, and then come back and watch the video, hopefully one will reinforce the other one. Naming of alkenes in IUPAC system is not terribly difficult in any case. Okay, so here's the rule. Very much like other IUPAC system names that we've learned, particularly alkanes, the first thing you want to do is find the longest chain. However, there's a trick here, because the two carbons that are connected by the double bond are such an important part of alkenes, you need to make sure that your longest chain has the double bond as part of the longest chain. Now that means in some cases there may actually be a longer chain, but you want to include both carbons of the double bond in your longest chain. So notice that in this molecule, the longest chain is in fact 1, 2, 3, 4, 5, 6 carbons long, and both carbons of the double bond happen to be in that longest chain. So that's fine, that's easy, that's a 6 carbon chain. But notice in this one, the longest chain is 1, 2, 3, 4, 5, 6, but both carbons of the double bond are not included in that longest chain. One is, but not the other one. So you have to find the longest chain that does include both of those. And so literally the longest chain is going to be 1, 2, 3, 4, 5, only 5 carbons instead of 6. So we're going to name this as a 5 carbon chain instead of a 6, even though there is a longer chain in the molecule. That's the rule. Okay, so this is going to be a 6 carbon chain with a double bond. So that's the first thing, find the longest chain. And it turns out we're going to count from the end closest to the double bond. So 1, 2, 3, 4, 5 in this case. And notice in this case, we're not going to start over here. We're going to start over here because that's where the double bond is closer to. It's not necessarily going to be carbon number 1 as it is in this case, but it's going to be closest to carbon number 1. So 1, 2, 3, 4, 5, 6, 7. Then you write the name of that alkane. In other words, the alkane that has that number of carbons, but with the ane ending changed to ene. So that one little vowel, ane, changing to ene, makes all the difference. So what I'm going to have you do is write down the name of the alkene with 5 carbons, or in this case, 7 carbons. That's easy. So this is pentene, and this is heptene. And then we have to do a couple things. We have to indicate where is the double bond, because it can be more than one possible position in a 5 carbon chain, and certainly more than one possible position in a 7 carbon chain. So what you do is you write down in front of the word, so in front of the word pentene or in front of the word heptene, in these cases, you're going to write the number where the double bond starts. So in this case, the double bond starts at number 1 and goes to carbon number 2. In this case, the double bond starts at carbon number 2 and goes to carbon number 3. In other words, write down the lower of those two numbers in front of it. So this is going to be 1 pentene, and this is going to be 2 heptene. So there you go, 1 pentene, 2 heptene. Then the rest of it's just a matter of finding any substituents that are attached to that longest chain and putting them in front with the numbers of the carbons that they're attached to, and you're already familiar with that. So in this case, what do we have? Our longest chain is through here, these 5 carbons, but then what is this thing that's attached to it? Well, that's a CH2, CH3, in other words, an ethyl group attached to carbon number 2. So this is going to be 2 ethyl, so 2 ethyl, 1 pentene. And this one has a number of groups besides the 7 carbons of the longest chain. It has a methyl group at carbon number 3, another methyl group at carbon number 4, and another methyl group at carbon number 5. So it's going to be trimethyl 2-heptene. So there you go, 2 ethyl, 1 heptene, and 3,4,5 trimethyl 2-heptene. Now one thing you'll notice is that this double bond has the possibility of being cis or trans because it has 2 different groups on this end, a methyl and a hydrogen, and 2 different groups on this end, a methyl and this whole great big thing here. So this could be cis or trans. Let's not worry about how you put the cis-trans name in front of it for the moment. We'll hold off on that until another video. So one more rule. If the double bond is equally distant from the two ends, then how do you know which end of the longest chain to number from? Notice this is 1, 2, 3, 4, double bond starting at carbon number 4, or 1, 2, 3, 4, double bond starting at carbon number 4 from either end. Well, then you have to use the first branch point, just as we did with alkanes. So which of these two ends has the first branch point closest? And that is, the answer is this one right here. So we're going to start numbering from this end. Similarly, this one, 1, 2, 3, 4, or 1, 2, 3, 4, which end are you going to start with here? And 1, 2, 3, 4, 1, 1, 2, 3, 4, which end are you going to start with here? Now, in some cases, it may not matter. It may be the same from both ends, in which case that's easy. But in all three of these cases, it does matter. And so what I want you to do is decide what the complete name is for each of these molecules. So I think you probably better stop the video, write down the complete name for all three of these molecules, and then come on back and we'll check it. Okay, we're back, and here you go. With this alkene, you're going to start numbering from this end because this methyl group is closer to this end than any substituent is to this end. So it's 1, 2, 3, 4, 5, 6, 7, 8. And so that's going to be 4-octene. And it's got methyl groups of carbon number 3, 4, and 5. So 3, 4, 5 trimethyl 4-octene. Again, this could be cis or trans. We haven't put that in front of the name, but that's going to be an important thing we'll learn about later. Same thing here. This is also 4-octene, but now the methyl groups are in slightly different positions. Notice that if we number from this end, 1, 2, 3, we get to the first branch point of carbon number 3. From this end, 1, 2, 3, we also get to the first branch point of carbon number 3. So then what do? Well, then you go to the next branch point. So starting from this end, 1, 2, 3, there's a methyl group, 4, 5, the next branch point is carbon number 5. Starting from this end, 1, 2, 3, there's a methyl group, and then another methyl group of carbon 4. So the second branch point is closer to this end over here, and so you're going to number it as I've shown. And then the methyl groups are 3, 4, and 6, and so it's 3, 4, 6 trimethyl 4-octene. And notice that this one's even more complicated because you get to the first branch point, 1, 2, 3. You get to the first branch point from this end, 1, 2, 3. You get to the second branch point from this end, 1, 2, 3, 4, 5, 6. You get to the second branch point, 1, 2, 3, 4, 5, 6 from this end. So how do you decide? Well, that's where you fall back on the alphabetical order. Since an ethyl group comes before a methyl group in the alphabet, we're going to number from this end. So it's 3-ethyl, 6-methyl, 4-octene. What about dienes? What if you have two double bonds in a molecule? Well, first you find the longest chain that includes all of the double bonded carbons. So even if there's an actual longer chain, in this case you would have to go through 1, 2, 3, 4, 5, 6, 7, 8. And secondly, you number from the end closest to the first double bond that you get to. So again, stop the video, just find the longest chain and number it. Okay, let's go see what the answer is here. We've got, first of all, find the longest chain that includes this double bond and this double bond. So even though there is an actual longer chain, this is actually 9 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to go with an 8 carbon chain as the longest chain because we have to include that double bond in it. And so we start here because that double bond is closer to this end than that double bond is to this end. So it's 1, 2, 3, 4, 5, 6, 7, 8 as shown. Second, we're going to change the ending to diene because there are 2 double bonds. And then we're going to put 2 numbers in front to indicate where the 2 double bonds are. So notice this double bond starts with carbon number 2, and this double bond starts with carbon number 5. So go ahead and write down the complete name with the 8 carbons, numbers in front to indicate where the double bonds are. Okay, so obviously octadiene, because we're changing the ene to diene. Notice there's an extra little syllable in there. That A is in there. If you left it out, I would not be worried about it. That's not really important. But the reason they call it octadiene instead of octadiene is just because it sounds better. Okay, and then the 2 and the 5 are there because the first double bond starts at carbon number 2, and the second double bond starts at carbon number 5. So 2, 5, octadiene. And then the rest of it is just going to be a matter of putting on any substituents on that longest chain. So put the names and numbers of any substituents in front. So notice that this then has a propyl group at carbon number 3 and a methyl group at carbon number 7. So it's 3-propyl, 7-methyl. Actually, I think that should be 7-methyl, 3-propyl if we put those in alphabetical order. Now, what about cyclic alkenes? How do you name them? Well, it's real simple. If there's a double bond in a ring, you simply write cyclobutene or cyclopentene or cyclohexene or whatever the size of the ring is. You put an ene in it. You don't need to number it. Why not? Well, because there are no differentiations between the carbons. No matter where you put the double bond, it's still going to be the same. So what would the name of this compound be? Well, that's real easy. I just said it's cyclohexene. But what if there are groups attached to it? Well, then all the carbons are not the same as each other, and you have to start using numbers. So the rule rule says if there are one or more substituents, the two double bonded carbons have to be carbons number 1 and 2. So you have to, so you know those two are 1 and 2, but you have to decide which one is 1 and which one is 2. The tendency is to want to put the 1 closest to the group, but it's actually the opposite. You want to put the 1 here and then the 2 here so that you get to the methyl group at carbon number 3. If you were to call that one number 1, then that one has to be number 2, and then you have to go around the rest of the ring that way, and you wouldn't get to the methyl group till number 3. It's real tempting to call this 2-methyl, because if that's number 1, then obviously the next carbon is number 2. But don't forget, both of them have to be carbons number 1 and 2. So if that one's 1, that one can't be 2. If that one's 1, that one has to be 2. That's a little bit tricky. So how would you name this particular compound? The answer is put a number 3 there. So 1, 2, and 3. And that's because, as I said, if that's number 1, then that one has to be number 2, and you don't get to the methyl group till carbon number 6. So this compound is 3-methyl cyclohexene. Now try naming these two molecules and see what you come up with. These are a little bit more complicated, obviously. So stop the video, work on it. Remember that the two carbons of the double bond have to be carbons number 1 and 2. You just have to decide which one is 1 and which one is 2. And then the same thing here. One of these has to be number 1 and one of them has to be number 2. So stop the video, and we'll be back in a minute. And we're back. Let's see what we come up with and see how that matches with what you came up with. Okay, so in this case, we're going to number, that one is number 1 and that one is number 2. Remember, the two double bonds of the alkene have to be number 1 and number 2. But if we choose that one as 1 and that one is 2, then the first branch point is at carbon number 3. So this is the way we'll number that one. Obviously, if we started with that one as number 1, we wouldn't get to the first branch point until carbon number 4. So 1, 2, 3, 4. That one's carbon number 4 either way, but the first branch point is at carbon number 3 instead of carbon number 5 if we number it this way. And similarly, if we start with this one as number 1 and number 2, we get to the first branch point at number 3. If we did this one as number 1 and that one is number 2, we'd also get to the first branch point at carbon number 3. So then we have to rely on the second branch point. So if we go 1, 2, 3, 4, second branch point's at number 4. If we did start with that one as number 1, that one is number 2, that one is number 3, that would be 4, that would be 5. We wouldn't get to the second branch point until carbon number 6. And so this is the preferred way in that case. Notice one little detail. Even though that's an ethyl group, which comes first in the alphabet, it doesn't have anything to do with the numbering system because we do have a way of distinguishing based on the second branch point, and that's more important than the alphabetical positioning. So this one is got an ethyl group of carbon number 3 and a methyl group of carbon number 4. So it's 1, 2, 3, 3 ethyl, 4 methyl, cyclopentene. And this is methyl group of carbon number 3, methyl group of carbon number 4, ethyl group of carbon number 7. So it's 7 ethyl, 3, 4 dimethyl cycloheptene. Okay, what about naming cyclic dienes? Well, you number the ring from one of the two double bonds as carbon number 1 and 2, and then you get to the second double bond as soon as you can. So we're going to, if we went this way, 1, 2, 3, 4, we would get to this, to the next double bond at carbon number 4. If we went this way, 1, 2, 3, 4, we also get to the second double bond at carbon number 4. So these are actually equivalent to each other. Either way is fine. But notice that it's 1, 2, 3, 4, not 1, 2, 3, 4, 5, because if you called that one number 1 and went 1, 2, 3, 4, 5, you wouldn't get to the second double bond until carbon number 5. So it's 1, 4, cycloheptadiene, not 1, 5. And what if you have a methyl group? Well, then it becomes more complicated. Now, not only do you have to decide which carbon is number 1 and which one's number 2, you have to decide which double bond to call number 1 and which one to call number 2. So notice if we started here, 1, 2, 3, 4, we get to the second double bond at carbon number 4, and move on around 5 and 6, we get to the methyl group at carbon number 6. If we started here and called that one number 1, 2, 3, 4, again we get to the second double bond at carbon number 4, but we don't get to the methyl group till carbon number 7. Obviously getting to the methyl group at carbon number 6 is better than getting to the methyl group at carbon number 7, so we want to number it from that one as carbon number 1, and that one is number 4, and then we get to the methyl group of carbon 6. So this is 6-methyl 1,4-cycloheptadiene, not 7-methyl-1,4-cyclopentadiene. And that ends this particular video. Thank you for your attention.